Welcome to an introduction to orthopedic driven imaging and our products currently focused on direct anterior total hip arthroplasty. Today we're going to highlight my role, Scott Banks, and that of one of our co-founders and Chief Medical Officer, Dr. J. Dean Cole. Together, we each have over 40 years in our respective pursuits. Dean has something around 40 patents licensed to many of the major orthopedic implant companies and has designed implants that have been used in hundreds of thousands of cases. My involvement has resulted in over 200 peer-reviewed journal papers that have been cited close to 19,000 times. I've developed fluoroscopic imaging methods over the past 40 years, and I too have designed implants that have been used in hundreds of thousands of cases. ODI started in 2022 with Dean and I speaking about the opportunities to quantify knee replacement kinematics. But as we advanced that conversation, we realized the ability to use advanced fluoroscopic imaging could have profound effects in so many other applications. So in 2023, we established Orthopedic Driven Imaging and put together a team that included some industry veterans on the fluoroscopic hardware and detector imaging side, as well as some industry leaders in startups and innovation with many successful corporate exits to their credit. For direct anterior hip, the motivating question from Dean was, how come I can use a AP radiograph, roughly 17 by 17 inches, from my clinic to plan my case, and then I can use that same radiographic modality to confirm my case, but intraoperatively I'm stuck looking through a relative keyhole with a much smaller detector. Is it possible to do something better? And Dean personally had gone through a series of technical evaluations beginning in 2009 and going up until the current day, evaluating templates, bigger and smaller C-arms, software for planning and execution, robotics, navigation, and some fluoroscopic imaging tools. But fundamentally, none of them delivered the ground truth that he was seeking, and that is a complete view of the pelvis with well-aligned femoral shafts so that he can do visibly excellent and trustable measurements of his implant placement. So what we set out to do as our first effort within orthopedic-driven imaging was to go from the typical 12-inch image intensifier to a 17 by 17-inch flat panel detector. As you see here, the difference is profound. With the 17 by 17-inch image, you get wonderful image quality, but you also get twice the imaging area that allows you to see the entire pelvis, as well as about the proximal half of the femurs bilaterally. And with all that anatomy in view, it's possible to get much better aligned images and to perform more accurate measurements. So here's an example, all done within the OR using the surgical ODI or SODI unit. On the left is a within the OR fluoroscopic shot that's acquired with the patient on the surgical table, the grayscale inverted, so it's white bone on black. That can be loaded into the hospital's PACS. Their current planning system can access that, and that planning image can be sent back to the OR for guidance. In the middle shows the use of the orthopedic-driven imaging hip guide touchscreen-based tools, all FDA approved. In this case, helping the surgeon align the acetabular component impaction. And then at the end of the case, as seen on the right, a perfect AP pelvis view with all of the annotations that are available from this full view of the pelvis with many pelvic landmarks and femoral landmarks to do those measurements of leg length, offset, inclination, inversion quite accurately. While ODI was evolving this imaging platform, we had to change the collimator, that is the beam area limiting device that sits in front of the X-ray source. While we were there, we took the opportunity to put a video camera such that it's optically in line with the beam and perfectly registered. So this allows us two things. One is the radiation technologist can introduce the C-arm into the surgical field and align it with the patient under video control. That is, they can get things lined up without having to use X-ray and expose the patient or the surgical staff. The other aspect is we have the ability with this video camera perfectly aligned to superimpose a video stream with the radiographic or fluoroscopic image. That allows us to superimpose, for example, hypodermic needles or percutaneous instruments that allows you to, again, guide a procedure without using as much X-ray as is required without that additional video guidance. A big part of our ODI effort is to add computational and AI support to many of the measurements that are commonly done within the OR. In this case, we already have a touchscreen or manual based software to measure hip arthroplasty component alignment and leg geometry during a total hip arthroplasty. And this is going to be supplemented with an AI-based auto landmarking capability by the end of this year. One of the key things that surgeons are always asking us is, what about the parallax effect? And what this refers to is that the appearance of an object, such as an acetabular cup, will change as its relationship to the center of the beam moves. And so what is commonly a concern is if the cup, for example, is not at the center of the beam projection, then you can't get an accurate angular measurement for inclination or version. We've taken care of that. So we, with our machines, know exactly and calibrate where the center of projection is. So when we project, for example, an acetabular component onto that screen, and we say that we want it, for example, at 40 degrees of an inclination and 20 degrees of anteversion relative to that projection, we can show the correct projection regardless of where that component is in the screen. It can be in any corner or the center of our 17 by 17 inch fluoroscopic detector, and we will accurately show those angles for that positioning within the image. Another clinically common circumstance that our technology facilitates a solution is when patients come with poor clinical x-rays. In this case, it was an orthopedic surgeon seeking Dr. Cole's care who came with an x-ray that you see on the left, which obviously has significant pelvic rotation relative to the beam. So it's not a good planning image, and being able to plan accurately from that is difficult. Well, again, if you can get a perfect intraoperative 17 by 17 image, then load that to the PACS and do your plan with a perfect AP film, then that facilitates a good plan using the ODI hip guide touchscreen tools, as you see here, to execute accurate cup and implant placement, and then confirming that all within the operative episode allows this confident installation of the hardware with the desired geometrical properties. So this is all available today. Our first product, the surgical ODI system, or SODI, is based as an upgrade to the OEC 9800 or 9900 C-arms, the world's most common C-arms, for which there's currently about 23,000 in the United States alone. We have the ability to take one of those older machines, do heavy maintenance on it for many of the common maintenance items, and install our all-digital imaging chain that includes the detector, significant computing resources, a tech monitor on the main C-arm unit, as well as other upgrades and our software. All of this is available today in the United States. It is FDA approved and available for commercial marketing. But our goals were not to simply contribute to hip arthroplasty cases. When we envisioned the start of orthopedic-driven imaging, we had a much more expansive vision. We envisioned using large dynamic detectors, as has been shown for DA hips, but we also wanted to be able to image, for example, the knee during the entire gait cycle, as you see in this graphic. We wanted to measure dynamic three-dimensional knee kinematics. As part of that, we decided we needed to add an instrumentation to the C-arm imaging platform so that a simple manual spin while recording the fluoroscopic images would provide adequate information to do a full 3D cone beam reconstruction of that target anatomy, enabling three-dimensional full 3D kinematics over time, or 4D motion analysis of the target joint. In addition, we wanted to architect our software ecosystem to have an open API so that with the suite of sensing and compute that we've endowed our systems with, third parties could actually contribute apps just like on a smartphone to take advantage of this rich ecosystem of sensing and compute that we've provided. So a system built with these four capabilities really isn't a single purpose tool. It's a platform for doing smart applications in the orthopedic space. So today we've got enhanced fluoroscopy focused on direct anterior hips. Soon, those measurements will be performed by neural networks and AI. Coming shortly thereafter will be 3D reconstruction and 4D kinematics that will enable a broad range of capabilities, both for the knee, the shoulder, the spine, and trauma. Here's an example of our 4D knee ecosystem where the model would be preoperatively do the scan and kinematics exam, which allows the most comprehensive possible surgical plan, perhaps using a digital twin model to plan it. You can use our SODI for surgical guidance and confirmation, and then back in the clinic, we can confirm the output of that surgery objectively. We can actually quantify joint motion. And then based on what we learn in those post-op analyses, we can actually turn that into a learning system that can then, at the front end, phenotype patients' joints and provide an optimal plan with subsequent confirmation. We believe ODI has a durable advantage in the marketplace. Whereas the large imaging companies have scale and really excellent general capabilities, they don't specialize in orthopedics. And so there's really very few products that provide the kind of added value that ODI seeks to provide to surgeons to enhance their workflows and their abilities in the OR. On the other hand, the large orthopedic companies tend to acquire and build their applications onto somebody else's stack where they don't necessarily have full control of the entire data flow. In our case, ODI owns the entire workflow from image acquisition, processing, visualization, and analysis. We own it all. We are committed to advancing advanced applications in orthopedics and building these platforms from the ground up with orthopedists for orthopedic surgery. Our market opportunities are many. Here's two. For example, the upgrade market opportunity with our SODI product has a very nice total addressable market in the hundreds of millions of dollars. And then with our apps, there's a software as a service model that easily could scale well beyond that. And that's before we think about opportunities to contribute apps and capabilities for trauma, fluoro-guided injections, the hands-on 3D reconstruction, joint kinematics, shoulder arthroplasty, spine, and other application areas. So if you're interested in what orthopedic-driven imaging is doing today, we're keenly interested to talk to surgeons and helping them put the SODI technology in their ORs. We are also interested working with the medical device manufacturers to develop those third-party apps that can run on the SODI platform and add value within each manufacturer's delivery model. And currently, orthopedic-driven imaging is expanding its commercialization and development efforts and is looking to partner in a new round of fundraising.